So section 2.2a, the notes will be called section 2.2 part A notes, and tomorrow will be part B notes. Today we're going to be talking about vertex form, possibly standard form. I can't really remember. We'll find out. So what is vertex form? Well, vertex form is called vertex form because it gives you one really important piece of information. The vertex. See, mathematicians are smart, but not necessarily creative. So what is vertex form? Vertex form is the form of the quadratic that shows you all of the transformations that have been applied to the parent function of f of x equals x squared. That's why this unit that we started yesterday begins with transformations, because vertex form shows you all of the transformations. So here you have the generic form a, and then in parentheses x minus h quantity squared plus k. The a on the front would be a vertical stretch or shrink of some sort. The h on the inside would have been you shifting this thing left or right some amount of spaces. The k at the end would have been you shifting this object up or down some amount of spaces. It's not on the generic here, but the vertex will always be found at what makes the inside equal 0, comma, the number to the far right. And I mentioned this yesterday, but positive people smile. Look, an upwards parabola. And negative people frown. Aw, a downwards parabola. So when a is positive, it looks like this. But when a is negative, it looks like this. That's just generic information. You can look at vertex form, you can know where its vertex is, and you can know which way it points. And with knowledge of transformations, that number on the front, if the number on the front is bigger than 1, you know it's going to look skinny. If that number on the front is a fraction between 0 and 1, you know it's going to look wide. That's just transformations. It tells you all of that. So for this first example, 1/3 and then x minus 4 squared minus 3. Just looking at it, what are some things that we know? We know its vertex. Can I get a volunteer to tell me the coordinates of its vertex? Wow. Okay. Let's remember, it's what number makes the inside equal 0, comma, the number to the far right. So Sam, what number makes the inside equal 0? It's 4. Yes, thank you. 4 makes the inside equal 0. And can I have another volunteer tell me what the y value is of the vertex? The number to the far right? -3. Yeah, there you go. Please don't overthink this, guys. The vertex will always be found at what makes the inside equal 0, comma, the number to the far right. It is that easy. You just tell me where the vertex is. What else do we know? Well, the number on the front, it's positive. So what does that tell me? Yeah, what's it tell me, Liz? Well, because, so he wants to know why the 4 is not negative. Your job is to figure out what makes this equal 0. So you say x minus 4 equals 0, and then you get x by itself by adding 4 to both sides. That's why. How about this? You know the parent function, y equals x squared? The parent quadratic, its vertex is at 0, 0, right? Your knowledge of transformations. If you see an x minus 4 on the inside, what kind of transformation is that? Do you remember? Shift which direction? Inside opposite. Shifts to the right 4, doesn't it? So it moved the vertex from x equals 0 to x equals 4. See, inside opposite. That's why it's powerful knowing transformations. That's why we harp on it so much at the beginning, because it really does tell you a lot. But basically, even if you don't know transformations, what you do is you just take whatever's on the inside, say it equals 0, and solve for x, and that will be the x value of the vertex every single time. What else do we know about this thing? It's positive on the front. What does it tell me? That it opens up. The fact that it's got a positive number on the front tells me that it opens up. Ooh, that's red. Well, whatever. And the 1/3 on the front. That is a vertical shrink, factor 1/3. So what does it make the graph look like? If I smash something down short, that makes it look wide, and it looks wide. Now, is it wide? No. Our knowledge of transformations by now is, yeah, we know it's actually shorter, but it's going to have a wide look to it, and that's all I care about. Do you know where it is, which way it points, and you generally know what it looks like? Do you know how many test questions you can answer just by knowing transformations? Because you know where the vertex is because of transformations, you know which way it points because of transformations, and you know if it's fat or skinny because of transformations. So many test questions can be gotten correct just by that knowledge right there. Or so many bad answer choices can be eliminated because of a knowledge of transformations. People always want to know when they're going to use this in real life. They go like, look, any of you ever plan on going to college? Have you ever going to have to take the ACT or the SAT? Do you know how many transformations I've used, my knowledge transformations I've used on standardized tests, when it's not even what it was asking for? All right, so our vertex, we already know, is going to be found at h comma k, and for us, that is, we already said it, 4 comma negative 3. So let's go ahead and put 4 comma negative 3 on our picture. 4 comma negative 3 is right here. Is that a question or a stretch? It's a stretch. Okay, gradient stretches with one arm in the air. All right, so axis of symmetry, your AOS. I can't remember if we've talked about the axis of symmetry or not before in this class. But the axis of symmetry is the line that cuts the graph in half. I mean, I've said that parabolas are symmetric several times this year. Remember when I was writing my t-tables? And I was like, hey, whatever y value you got at the bottom, you had to match at the top because these things are symmetric. That's because parabolas can be folded in half. And that vertical line that goes right down the middle is called the axis of symmetry. If it goes right down the middle, what that tells you is that it's automatically going to go through the vertex because the vertex is right down the middle. So the axis of symmetry will always be x equals, and it will be the same x value as your vertex, which is h. So x equals whatever h equals. They have the exact same x value. The axis of symmetry has the exact same x value as the vertex. So for us, that means that x equals 4 is our axis of symmetry. I'm going to graph this as a dotted line, and I'm going to do it in red, and that's why I wrote it in red. The dotted line is not actually part of the graph. It's a property of the graph, but it's not actually part of the graph. The graph will be in blue. But this red dotted line is the line that cuts the graph in half. Whatever happens on one side of it happens on the other side of it. Folds in half there. Wow, wouldn't it be great if I had another point to plug in so I could actually graph this thing? I mean, shucks, shoot, darn. If only I knew how to find another point. Oh, that's right. I taught you a trick way, way, way back at the beginning of the year. And it was a while ago. It's already 5 weeks ago. There's a 1/3 on the front of that quadratic. So how far from my axis of symmetry should I move to pick the next good x? Nick? He showed me 3 with his fingers. Yeah. The bottom of the fraction is a 3. So I'm going to go to the left 3 and to the right 3. So I'm going to plug in that x or that x. It doesn't matter because they're going to have the same y value. Just pick one of them. I like to move to the right. How come? Because I don't want to have to mess with negative numbers. That's why. If I don't have to, I try not to. So I'm actually going to plug in x equals 8. Is it 8? 7, excuse me. Plug in x equals 7 because that is 3 to the right of my axis of symmetry. Let's see what we get. Y equals, and it's 1/3. Here's me plugging in my 7. Wow, that was loud. Minus 4 squared minus 3. And this is why we practice the order of operations at the beginning of the year. 7 minus 4 on the inside is 3. Well, there's a lot of 3's on that board. Order of operations tells me exponents are next. So I have to do the 3 squared, which is 9. Now I have to handle the multiplication. And instead of saying 1/3 times 9, because maybe that's hard, what's 1/3 of 9? 3. And then 3 minus 3 is 0. Oh, so when x is 7, y is 0. How about that? Which means when x is 1, y has to also be 0 because it's a symmetric graph. And you can do this. Whee! Yeah! Just like that. Feels good, doesn't it? That means whatever you got on the mid-chapter test doesn't exist. Yes, sir. Yeah. Questions, comments, concerns, curiosities? It's a lot of C words. Anything that you want to talk to me about for vertex form. Anything at all, please. Ben, yes. Uh-huh. So how did I get y? And that's a really important question to ask. Technically, I could plug in, you mean how did I get y equals 0? How did I know to go to x equals 7? On the x-axis? Oh, okay, so don't worry about the fact that it's 3 points up. Are you comfortable with the fact, are you comfortable with why I chose x equals 7? Yeah. Oh, great. What I did was I plugged in x equals 7 because you know when it says f of x equals, that's just a fancy way of saying y equals. So when you plug in x equals 7, it's going to tell you what the y value is. And that's why I wrote y equals every single time. So when I plugged in x equals 7, I ended up getting that y equals 0. That tells me the coordinate is 7, 0, which is on the x-axis. And whatever happens on the right side happens on the left side. More comfortable now? Good. So everybody's cool with why we went to the left 3 and to the right 3 of the axis of symmetry. Everybody's cool with that idea? Okay. I certainly hope so. All right, well, I'm going to go ahead and clear it then. Clear. This is, yes, question for me? Should I bring it back? Yeah. So, yes, the fraction is 1/3. Yes. So the top of the fraction, so the question is the bottom of the fraction tells me how far to move left and right. What does the top of the fraction do? Let me give you an example. Let's say the fraction is a 2/3 instead of a 1/3, okay? Just for example, if it was a 2/3, you would still move to the left and right by 3 away from the axis of symmetry because you don't want to mess with decimals. So what does the 2 do? Well, when we said here that it looks wide, we said that because 1/3 makes it short, right? So let's say there hadn't been a fraction. Let's just say it was the number 2 on the front. If a fraction made it look short, then the 2 would have made it look tall, correct? You're not grading. Gavin. Graydon was behind you. Here you go. So if a 1/3 on the front makes it look short, we said that a 2 on the front would make it look tall. Are you comfortable with me saying that that 2 on the top of a 1/3 is actually me saying 2 times 1/3? Is that comfortable? You okay with that? Well, if you had 1/4 and I gave you 2 of them, you'd have 2 quarters, right? So the top of the fraction can actually be brought to the front as a multiplication. So what does the 2/3 do compared to the 1/3? The 1/3 still tells you move to the left and right by 3. The 2 just means it's twice as tall as the one that had a 1/3 in front of it. That's all that means. So you can think of it as a separate transformation if you wanted to, but it doesn't affect the left and right motion of you choosing x's, I could say. Okay, so yeah, the number on top is just something you're going to multiply by. Okay. That's a good question. I don't think anybody's ever asked me that. Vertex form. How did I know vertex form? I recognize vertex form because it looks like a bunch of transformations and because legitimately there's a set of parentheses with an exponent on it. The moment you see a set of parentheses with an exponent on it, this is vertex form. It screams vertex form. I'm going to say it again. A set of parentheses with an exponent on it is vertex form. Is vertex form difficult? No. Is standard form difficult? No. Is intercept form difficult? No. But if I just hand you a quadratic and say, do some stuff to it, and you can't figure out what form it is, you're going to have no idea how to do the stuff. That's what makes this difficult. Difficult, he says with air quotes. Again, a set of parentheses with an exponent, vertex form. All right. First things first, since it is vertex form, can I get a volunteer? Maybe one of my peeps at home. Come on, guys. Can one of you tell me what the x value of the vertex is? None of you? One of my peeps at home? Come on, there's 6 of you. Give him a sec or a snack.
-1.
My man, Juan. Was that Juan? You're small. Is that who said it or no?
Yes.
Awesome. Thank you, Juan. Yeah, it's -1. Because that's what makes the inside equal 0. Boom. And how about someone in the room? I mean, Catherine, you've already helped me with this. And someone else in the room, Dalen, what would be the y value of this vertex? -6. Thank you so much. It's the number to the far right. Awesome. Please let whoever that is in. There it is. There's your vertex. -1, -6. Please don't make this hard. It doesn't need to be hard. -1, -6 is here. There we go. The axis of symmetry is the vertical line that cuts the graph in half. So can I get someone to tell me the equation for the axis of symmetry? Lewis? That you're telling me where it crosses the x-axis. I need the equation of the line itself. Well, go back to the previous example. I had a white box on it. I said that the equation of the axis of symmetry is always x equals h. So what would this one's axis of symmetry be? It is the line that goes through the vertex. But it has to be an equation. It has to be letter equals number. Don't overthink it. You know it goes through the axis of symmetry, right? So it is the x. So, but you would have to say x equals -1. It is just -1. But you do have to say x equals -1. You see, if you don't say x equals, it's not a line, it's just a number. But the moment you say x equals, it's a vertical line. If you say y equals, it's a horizontal line. And that's why we're also specific. That's why I make you tell me the letter. Because, just so you know, there are such things as sideways parabolas. And they have horizontal axis of symmetry. So it's important that we say x equals. Now, we're not going to do the sideways parabolas in this class this year. But you will in the future. So it's important that you say x equals. And let's graph that as a dotted line. Thanks, Lewis. Appreciate you. Let's graph that at x equals -1, like so. Before I do anything else, the 2 on the front is a positive number. Can I get a Zoomy to tell me what a positive number on the front tells me other than 1, since he already helped me? Number on the front's positive. What do I know, Zooms? I'm going to start calling people out. All right, Ryan, mic up. Positive number on the front. What do you know? He's He's not even turning his mic on. Do you have a microphone, Ryan? There he is.
Yeah.
Positive number on the front. What do you know? What do positive people do, Ryan?
Huh?
What do positive people do?
Up.
They smile. Yeah. Positive people smile. Look, because the front number is positive, you know this thing points up. That's powerful knowledge. You just eliminated half of the bad answer choices on a test. Anything that points down? Wrong. Don't pick it. You see how easy this is? Okay, how about someone in the crowd? 2 on the front. We know it points up, but what's it going to make it look like? A 2 on the front. You guys have already helped me. I really appreciate you 3. But there's a whole room full of individuals that rarely speak to me. I don't even think I've ever heard Nadia's voice. She's like, uh-oh, I should have been on my phone. Anybody else, can they tell me what the 2 does? What it's going to make it look like? Yeah, okay, Ben, what do you know? It does stretch it, so it's going to make it look, well, it will be taller. But yeah, it's just going to make it look skinnier. But yeah, no, you're right. You're absolutely right. It will be taller. It's going to look skinny. So I know what this thing's vertex is. I know it points up. I know it looks skinny. Powerful stuff, guys. The number on the front's not a fraction. So how far should I move from my axis of symmetry? How far? Well, I could move 2, but it's not a fraction. So when it's not a fraction, it's easier to move by ones, okay? Were you going to tell me 1? It will, but they don't know why. So I'm not going to, you're not wrong, but they don't know that. Did Miss Bluebaum teach you that? Yeah, see, they've never seen that, but yeah, that's absolutely true. If you know that, awesome, use that knowledge. So what I want to do is I want to stay close to my vertex. Because the number on the front is not a fraction, just move by ones. Plug in a number that's to the left 1 or to the right 1. That means I'm going to be working with x equals 0 and x equals 2. I'm going to plug in one of those. I like going to the right. So I'm going to find out what is y when I plug in x equals 0. Here's me plugging in x equals 0. Well, 0 plus 1 is just 1. And 1 squared is, yeah, it's just 1. And 2 times 1 is 2. 2 minus 6 is -4. So I have the coordinate 0, -4. That's right here. Whatever happens on the right side of the dotted line happens on the left side of the dotted line. Yeah, that thing's pretty skinny. At least it looks it. Boom, just like that. That's it. That's all you have to do. If you have any questions for me, you ask them. Let me help you. Anything, please. Graydon, I feel like you almost have a question.
I'll wait for the next question.
Well, no, that's it. That's the notes.
Oh, that's it.
Yeah. What we're going to do now is just extra examples. So if you, what about it where you almost asked a question about? Which part?
So when you got that line,
The vertical line, the axis of symmetry, yeah?
still don't get how you got that.
Okay. Well, are you comfortable with the fact that parabolas are symmetric, that I could fold them in half?
Yeah.
You cool with that idea?
Yeah.
Are you comfortable with the idea that if I were to fold it in half, that fold would have to go through the vertex?
Right.
So imagine you drew a parabola on a piece of paper, you put a dot at the bottom of it, or at the top of the parabola, because it could be a downwards parabola, who knows. You fold it in half. Now you unfold it. You seeing it in your head?
Yeah.
The fold, that is the axis of symmetry. Well, it's a vertical line. All vertical lines are x equals number. All vertical lines are. And all you have to do is tell me, well, what was the x value of that vertical line? Well, since the vertical line went right through the vertex, it has the exact same x value. So you just say x equals this, and now you have your dotted line.
All right.
Cool?
Yeah.
See, that's a good question. I'm not going to lie. You have test questions that say, what's the axis of symmetry? I mean, they're that easy. I have test questions that are that easy. And if you say -1, you just got half credit. Because you have to say x equals -1. Okay? But we'll get there. So let's do some practice. Let's do some practice. I've got a generic grid up for us, and I'm asking that you just do some stuff with me. I want to know, can you identify what this graph looks like? Can you tell me what its vertex is? So can you tell me its vertex, the axis of symmetry, what it looks like, and graph it? So I'm looking for vertex. I'm looking for the axis of symmetry, known as the AOS. And what do you know before you even graph it? And then I'm asking you to graph it. And now that we've had some think time, do I have a brave soul out there that wants to tell me the vertex? Catherine, brave soul. -1, comma 3. Perfect. Vertex at -1, comma 3. Fantastic. We know this is the vertex because -1 would have made the inside equal 0, comma the numbers to the far right, 3. So -1, comma 3 is right. -1, comma 3 is right there. And hold on one second, forgot to save this. You're not wrong. I just want to save my flip chart. I forgot to save it. And that is important that I do that. There we go. So you said -1, comma 3. Put the dot right here. Perfect. Can I have somebody else tell me what the axis of symmetry is? Graydon! X equals -1. My man remembered the x equals. Good. X equals -1. Without the x equals, half credit. We don't want that to happen on the test. Now this dotted line is just a property of the graph. It's not actually part of the graph. We imagine it's there. Before we do any more graphing, can someone tell me something they know about this graph? Hey, Catherine, I appreciate you so much. And same thing, Dalen, Catherine, and Lewis, I appreciate you guys so much. There's just so many people that I never hear from. Like, I don't know if I've ever even heard Caroline's voice. Livy never even looks up from the phone. Nadia's now looking at me. But I've just, like, the only reason why Jay Sean's ever talked to me is because I've talked to him. I mean, come on, guys, help me. You know, Kevin also never looks up from his phone. He's not even taking the notes. There's just so many people that I never hear from in this class period. You're a whole class of people. And I would love to know all of you. So he's telling you the answers. What? Anyway, so I just want to know, can somebody else tell me something they know just by looking at the equation? I just mean, Nick, just by looking at f of x equals -1/2, yada, 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 can you tell me something you know about this graph? Like, tell me, Nick, which way does it point?
Up.
And why would you say up?
Because of this possible. Wait. Oh, it's because of the square. It means it has that.
Well, because of the square, it means it's shaped like a U.
Yeah.
But the number on the front is negative.
No, down.
So it points down. How come? Because negative people frown. Oh. So because that front number is negative, you know this thing points down. You know it points down because it's negative on the front. Points down. And that number on the front is a 1/2. Can somebody else tell me what that's going to make the graph look like? Maybe one of my Zoomies at home. Juan's already talked to me. I've already put Ryan on the spot. I've got 4 more of you. Can one of you tell me what you know the 1/2 is going to make this thing look like? Casey, come on. You know, don't you? She's just looking at me. Jeremy? I mean, I have people here whom I've never spoken to. Well, I mean, I speak to you all.
I didn't hear you.
Casey, she didn't hear me. She must have had me shut off. The 1/2 on the front. Do we know what that makes the graph look like?
Is it?
Meaning, is it going to make it, when we talk about look like, we mean like looks wide or looks skinny. So what's the 1/2 going to make it look like?
Skinny?
It's going to make it look not skinny. But why is the real question. 1/2 on the front. This is a vertical shrink. So if I were to smash someone down real short, wouldn't it make them look kind of wide? Imagine you squashed a Play-Doh ball between your hands. It'd poke out wide, wouldn't it? So that 1/2 on the front is going to make it look wide. That's okay. And that's why, you know what's great about this? This gives us the opportunity to talk about transformations. Again, since they're going to be on the test, you might as well know how to do them, right? There. Now, I have my axis of symmetry. It's at x equals -1. How far should I move left or right to pick the next point? 2. How did we know that? Yes, the bottom of the fraction. So the bottom of the fraction is a 2. It tells me I should go to the right 2 or to the left 2 to pick the next good x. I try not to mess with negative numbers if I don't have to, so I would like to choose x equals 1. So I want to know, what will y be when I plug in x equals 1? So I plug in x equals 1. I'm curious to know where I'm going to land. Let's find out. Well, y equals 1 plus 1 on the inside is 2. Now, you have to use exponents. So that 2 to the second power means 2 times 2, that's 4. Now I need to know what negative 1/2 times 4 is. Ooh, maybe that's tough. Maybe we do it separate. Instead of saying times, let's say of. What is 1/2 of 4? 2, but it's got a negative sign. So it's negative 2. Sam, you got a question for me? Yeah, what's up?
Why did you put it 1?
Because I don't want to have to graph a decimal, because plotting decimals kind of sucks. So what I did was, the trick is this number down here, whatever the number on the bottom of the fraction is, tells you how far you have to move to avoid decimals. Do you have to move to the right 2? No. You're welcome to move to the right 1, you're just going to end up plotting a decimal. And I don't like plotting decimals. It just doesn't feel accurate enough. But you can. If you're comfortable with it, go for it. But I don't like to. So I would plug in, x equals 1, because I know for a fact I won't get a decimal there. And in fact, negative 2 plus 3 is positive 1. So that coordinate was, when I plugged in x was 1, I actually got back y equals 1. And if there's 2 to the right of the axis of symmetry, there's one that's 2 to the left of the axis of symmetry, and you can connect your dots. Just like that. What do we think about that? You have a question, fantastic, and I would love to answer it. What can I do for you, Nick?
You used 1 because you moved to the right to
Yes.
negative 1.
Yes.
So you used something other than the x value that we were given. So 1 would give you a decimal and 1 would give you a non-whole number. So how would there be 2 answers to that?
Okay, so, and I have to repeat because you're in the back, so the mic probably didn't pick it up. The question was, so you knew we moved to the right 2 because the bottom of the fraction was a 2. And you were saying that if we plugged in the wrong number, we'd get a decimal. Quote unquote, the wrong number. I mean, you could plug anything you want. So this is what Sam was saying. He wanted to know why I moved to 2, right? Well, let's say I don't move 2. We'll just move to the right 1. Let's just move to the right 1 and see what happens. If you move to the right 1, you're at 0. Cool with that idea? Like right here, let me use a different color. Right here, x equals 0. So if I plug in x equals 0, let's get a new y value. Let's just plug it in. You get y equals this negative 1/2. Is it a plus 1? It is. So I'm going to plug in x equals 0 now. Well, 0 plus 1, and let me scroll. 0 plus 1, of course, is 1. Well, 1 squared is still just 1. Anything times 1 is always going to be itself. And if you grab handy dandy calculator and you do negative 1/2 plus 3, you will get 2.5. So there should have been a coordinate at x equals 0, comma, y equals 2.5. Right there. So it's not that it's a different answer, it's that it's a different coordinate on the curve. I just didn't want to have to plot a decimal. But you can, if you are comfortable with it, you can. So you see, it still landed right on my curve. Okay?
So you can use, you could just go into the right 1 and using a 0.
Yeah.
The right 2 and using 2. So you can use any number.
You can use any number you want, yeah. Generally, you want to try to stay close to the axis of symmetry because these things grow really fast, so the y values get big quickly. So the closer you are to the axis of symmetry, the smaller your y value is going to be. That way you can guarantee it fits on the grid. You know, I mean, my grid stops at 10s, but you know there's more numbers. So could I have plugged in x equals 10? Absolutely. But I would have gotten the y value somewhere in the really far negatives, close to negative 20 or something like that. So yeah, you can plug in any number you want. I try to stay close to the axis of symmetry, and I try to avoid decimals. That's just me. Sam.
Wouldn't the, okay, so the vertex, wouldn't it be down 1 and over 2, not down 2 and over 2?
My vertex,
For the graph.
so negative 1 comma 3.
No, like from the vertex, wouldn't it be down 1 and over 2?
So you are attempting to use transformation tricks. Normally, the vertex is up 1, right 1, correct? Right? Well, the left and right has not changed because the number on the front is a y transformation only. So I could still go left or right 1, but the y change has changed from a 1 to a 1/2. And that's why I don't use those tricks, because that confuses people. So what you described doesn't work that way. And that's why I have them choosing numbers that will avoid decimals. This way they're not trying to use transformations to cheese the next point, because it's harder to do it that way. Okay? So trust me on this one, it's just much easier. You're going to avoid a lot of frustration. Just try not to plug in decimals. And what you're talking about works for stretches only. It doesn't work for shrinks very well. That's the problem. Okay? And that's why I didn't teach them that, because it confuses people when you go, well, the rule works sometimes, but not always. Like, then it's not a rule, is it? It's like sometimes there's a trick, you know. Yeah, but that's it, guys.